So welcome. My name is Kim Umbach, and I'm the volunteer coordinator at PWRDF. My colleagues, Janice Bean, our communications coordinator, and Suzanne Rumsey, our public engagement coordinator, are going to be sort of co-facilitating the process. Also want to welcome our presenters, Kevin Muneene from Utooni Development Organization in Kenya, and welcome to many of his colleagues as well who are able to join us today. And my other colleague, Richard Librock, who will be presenting today. So in a couple of seconds, I will be introducing Suzanne, who will do the formal introductions of our presenter. Kevin will be speaking for about 20 minutes on a conservation agriculture food security program that UDO is working on. Many of you from our parishes may remember Utooni Development Organization as a partner in which we have a shallow well project with. But of course, that's just part of the work that they do. So today we'll be learning a little bit about another project that they're working on that isn't necessarily one that we're funding, but again, shows just the breadth of work that our partners are doing locally. Then we will have a little bit of time for question and answer for Kevin, very short, and then Richard Librock will kind of talk a little bit more, go a little bit deeper into why conservation agriculture is an important way to address climate change. We'll have a few more questions for Richard and Kevin, and then Suzanne will be introducing us to our first learning module as part of our education focus, creation, care, and climate action. And we'll be focusing on food security and climate change. And so Suzanne will be sort of sharing that a little bit later in the. So let's get started. So Suzanne.
Thanks, Kim. I'm Suzanne, the Public Engagement Coordinator at PWRDF, and it's my pleasure to introduce Kevin Muneene Kamuya, who has a lifelong interest in community development with a focus on changing lives. He has been working with rural communities in Kenya for 10 years, 8 of those with UDO, the Utooni Development Organization. And through that work, he has been enabling them to improve water supply, food production, income, and health. In 2014, Kevin received the UNDP Equator Initiative Award on behalf of Utooni Development Organization for promoting sustainable land management practices. And in 2015, he was accredited to the United Nations Convention for Combating Desertification Observer status. We are deeply grateful to have Kevin join us at this time, as he and his family mourn the loss of Kevin's uncle, Peter Moema, to COVID-19 just recently. So a personal word from all of us here at PWRDF of condolence to you and your family, Kevin, and a big thank you for being with us today. So I'll turn it over to you.
Yes, thank you very much for that introduction, Suzanne. My name is Kevin Kamuya, and I'm the program manager at Utooni Development Organization, a non-governmental organization partnering with Mycorrhizal Relief Development Fund in implementing a multi-year shallow well project in Kenya. Our mission as a non-governmental organization is to improve water supply, food production, income, and health among its vulnerable community members. The Conservation Agriculture Project has had a positive impact on participants in numerous ways. On food security, new livelihood opportunities, and reduced labor requirements. These impacts have been well documented through regular reporting and project evaluation activities. The program has had an impact on participating members and partners, how these organizations work together within networks, and how the participating organizations have engaged other stakeholders to advance the project goals of the Conservation Agriculture Project. The Scaling Up Conservation Agriculture Suka program in East Africa was a 5-year program that was carried out in 3 counties in Kenya, that is Machakos, Kajiado, and Makueni. And it was carried out by Canadian Food Grains Bank and three of its members, that is Mennonite Central Committee, Tear Fund Canada, and World Renew, and 11 of their implementing partners in Ethiopia, Kenya, and Tanzania. Utooni Development Organization was one of the organizations that were implementing the project in Kenya. The project was funded by Global Affairs Canada. UDO targeted 5,500 farmers in this project, enabling them to adopt conservation agriculture in order to reduce cost of labor, inputs, and to improve yields. By the end of the project, UDO had more than 6,000 farmers trained on conservation agriculture. On that photo, you can see Bendeta Mutua, a farmer working with the Utooni Development Organization in Makueni County, Kadhonzweni sublocation. She is married and has 4 children. Before conservation agriculture, she used to get very low harvest from a 4-acre piece of land because of soil infertility and erratic rainfall. Farmers entered the conservation agriculture project with varying levels of experience. Some had implemented conservation agriculture principles previously, while others had no experience with conservation agriculture. Most farmers had no experience or knowledge on conservation agriculture, and that is why Utooni Development Organization decided to intervene and promote conservation agriculture amongst these communities members who were facing different challenges. The conservation agriculture promotes 3 principles. And the first principle is minimum soil disturbance, which is one of the pillars on which conservation agriculture rests. It is to avoid, so far as possible, mechanical soil disturbance while carrying out agricultural activity. This is made possible by using fabricated tools like reapers, subsoilers, dab planter, and weed scrapers, which enable farmers to plant and carry out weeding without disturbing the soil. As you can see on the photo, we have planting basins and hand furrows which have been manually done. Next slide. The next conservation agriculture principle is intercropping and crop association. Minimum soil disturbance is combined with intercropping and crop rotation, which means either growing 2 or more crops at the same time on the same piece of land, or growing 2 different crops on the same land in a sequential manner. These are also core principles of sustainable intensification. As you can see on the photo, this is a farmer who has intercropped beans, maize, and cowpea. Planting the right mix of crops and rotating crops from season to season helps to break pest, disease, and weed cycles. The next conservation agriculture principle that Utooni Development Organization promotes is permanent soil cover with living or dead plant materials or residue. Soil cover saves water, gradually increases soil organic matter, and suppresses weeds, as well as reduces cost of machinery, fuel, and time associated with tilling. Leaving the soil covered and undisturbed increases water infiltration, holds soil moisture, and helps to prevent topsoil erosion in arid and semi-arid lands where it really gets dry during extreme dry season. In the 5 years that Utooni Development Organization has been promoting or upscaling conservation agriculture with its community, our results suggest that smallholder farmers who adopted conservation agriculture had increased production, saved natural resources, and improved yield and reduced labor. 47% of households reported acceptable food consumption score, that is FCS. 97.8% of female-led households reported achieving a minimum dietary diversity score, that is MDDW, and 80% of women, compared to 84% of men, now rely on preferred or less expensive food strategy. There were 6,307 farmer households reached out by the Conservation Agriculture Project. Out of that, 4,705 households were led by women, and 1,602 households were led by men or male-aided households. Months of adequate food provisioning increased from 8 to 12 months. Percentage of farmers practicing at least 2 conservation agriculture principles increased from 36 to 97% for female-aided households and 20 to 81% for male-headed households. Generally, the number of female-headed households reporting improved food security increased by 17% and 2% for male-headed households. The average yield of selected crops per quarter, an acre, was significantly improved amongst farmers practicing conservation agriculture. The sizes of land under conservation agriculture differed from one farmer to the other. But the approach that we use to promote conservation agriculture amongst our communities is that we advise them to start small and grow big. And that's why we were very successful in helping many community members to adopt this farming practice. And on average, yields increased for crops like beans, green grams, cowpea, and maize, as shown in that table, commonly grown by most of our farmers. This improved yield can be attributed to improved soil fertility, soil moisture, and choice of crop grown by farmers. The man with the blue cape on the photo that you can see there is Pastor Mbithi, a religious leader and lead farmer working with the Utooni Development Organization. Pastor Mbithi has been practicing conservation agriculture for the past 5 years. This photo was taken on his farm where UDO was conducting a farmer field day in the community. He is demonstrating indigenous seed varieties from his mini seed bank. Farmer field days are production focused on farm workshops to help farmers and stakeholders get practical information that they can use to plan or enhance their own operations. Utooni Development Organization is proud to partner with farmers and stakeholders to share success and challenges towards upscaling conservation agriculture all over Kenya in order to improve food security and livelihoods. Balancing between livestock fodder and mulch can be tricky for some farmers. Embracing livestock integration with conservation agriculture for the healthy mutual benefit coexists between the livestock and the farm. That is one of the key aspects of conservation agriculture, is soil fertility, which is achieved through use of manure. Therefore, livestock is needed for manure, which results to improved soil fertility. The photo shows a farmer who has cut upper part of maize stalks, giving the upper part to the livestock and leaving the rest for the soil. The lady on the photo is Joyce Ngumbao from Kibwezi, Makueni County in Kenya. She has planted a lot of Dolichos lablab on her farm. The crop covers her soil well, suppresses weeds, and helps retain moisture in the soil. She reports reduced farm labor because she does not have to do regular weeding on her farm. She gets money from selling the Dolichos lablab in her community. She plans to continue putting more land under conservation agriculture, having experienced good results so far. During an interview with her, she told us that before she started practicing conservation agriculture, her husband was not very sure if it was going to work on their farm, and so her husband decided to let her practice conservation agriculture on the least fertile part of their land. But eventually it did very well until her husband asked her to put more land under conservation agriculture. So this is the result of continued efforts and experience in conservation agriculture, which is enabling spouses to compare and also get to see how best they can utilize their farms as a couple. One of the challenges that farmers reported is lack of conservation agriculture tools like reapers, subsoilers, and weed scrapers. Utooni Development Organization trained local artisans in the community to fabricate conservation agriculture tools and sell to communities at cheaper prices. So far, many of our farmers have fabricated conservation agriculture tools, and supply has improved over time. Because when we started this project, most community members complained that the price of conservation agriculture tools was very high, because also the supply was not available. And therefore we bought a few original tools, and then we trained a few artisans with the models that we had bought. Then from that they started fabricating cheaper tools for our farmers, which are much more affordable. For more information about conservation agriculture and Utooni Development Organization, you can visit our website at www.utoonidevelopment.org. You're going to find more information about our projects. We have projects on water. We do projects on food production, income, and health. Thank you very much for listening.
Thanks very much, Kevin. That was a lot of information in a short space of time, but we've got a bit of time then for a few questions for Kevin. So we'll take about 5 minutes before we pass on to Richard. I saw a question in the chat coming from Kate Woodman. She says, would like to know how the yield increase, almost 3 times, doesn't seem to correspond with household food security, so that the food security has not increased 3 times as the yield has. Can you speak a bit to that, Kevin?
Thank you very much for that question. I would like to say that food security, this project was a 4-year project. And the last evaluation that we did was during the end of the fourth year. And by then, we had achieved food security for most households had improved, was at moderate level. And therefore, I would like to say that conservation agriculture will take a longer span of time for community members to be food secure, because building mulch takes quite a lengthy time, and therefore without enough mulch, you cannot improve crop production. And therefore, as we proceed and go on promoting conservation agriculture, we'll be able to measure and also get new data on how conservation agriculture is improving food security among the community members that we are working. Thank you.
Thanks, Kevin. Another question posed by Polisi is, what about hillsides with land erosion? How are you addressing issues of erosion with the farmers?
The issue of erosion is being addressed through promoting soil cover. You see, when you promote green cover, that is creeping cover crops like Dolichos lablab. You promote crops like pumpkin and some crops like sweet potato vines, which creep and cover the soil. You reduce soil erosion drastically over time as community members continue to maintain soil cover. Also, you find that soil erosion is also largely prevented. With regard to hillsides, with land erosion, hillsides, we also promote terracing to reduce runoff in hilly places, which is also a component in our conservation agriculture project.
Thanks, Kevin. Naomi asked a question about the website link for Utooni, and I see Janice has put it there in the chat. Everyone can see it there at utoonidevelopment.org. And then Sally asks, and Naomi, I see you've got your hand up, but I'll just get Sally's question then come to you. Sally asks, what did they do prior to conservation agriculture? What is the big change in practice?
Oh, thank you very much for that question. What we were doing prior to conservation agriculture is we were implementing a water project with community members, constructing sand dams and along seasonal rivers. Sand dams are concrete structures which are constructed along seasonal rivers in order to harvest water during the dry season. And it uses a method of storing water under the sand. That's why it's called a sand dam. You find that it's 60% sand and 40% water. And these are projects that we did for quite a long time. And Utooni Development Organization is very much known for promoting the sand dam technology. About the big change in practice, I like to say change in mindset. And is one key change that we've managed to influence in our community members, where community members now are adopting to new farming approaches which are more sustainable in order to mitigate effects of climate change. And over the past years, we've seen quite a lot of change in attitudes, and many community members are adopting new farming and sustainable farming practices in order to combat or maybe build resilience against climate change effects.
Thanks, Kevin. I'm just conscious of time, so we'll take one more question, and then if we haven't gotten to your question right now, we'll make sure we come to it after Richard has spoken. I see one. I see another by Polisi related to the question, I think, of hillside erosion. Which trees do you promote for planting? In my area, I have to struggle against eucalyptus.
Oh, thank you very much for that question. We are very much keen in promoting or improving food security amongst community members. And the decision of the trees communities want to plant is majorly decided by the communities themselves. We don't impose solutions to community. As much as we promote growing of trees, the most commonly trees grown in this area are fruit trees because they also help in improving food security at household levels. And the most commonly grown fruit trees are mangoes. We also have citruses, that is lemons and oranges. We have lots of farmers also planting pawpaw. We have farmers who also plant fruit trees like avocado. Avocado is very common here in Kenya, and it does very well. And recently, the country also got a contract to export us avocados to the Western world and also in Asia. And this is going to provide a very good avenue for our community members to improve food security and also income. There are other trees which are not fruit trees, which we also promote amongst our communities, trees like Grevillea. And we also have some farmers who plant some cypress, depending on the areas that they live in, and other exotic and indigenous trees which are largely available. What we like to do is that we like to advise community members to plant the trees that do well in their areas. It's more sustainable and it's much easier for them to access seeds. Farmers can exchange seeds and germinate seedlings on their group tree nurseries. Thank you.
Thanks, Kevin. I think we'll move on. I see some other questions popping up, and we'll make sure we get to them at the second time for questions. Right now, I'd like to introduce Richard Librock. Richard, who is has worked at PWRDF since 2014 as the External Funding Program Manager. He is a certified educator in holistic management and one of the founders of the Participatory Ecological Land Use Management Network of more than 200 member organizations that promote sustainable agriculture in 12 countries of Eastern, Southern, and Central Africa. Richard, as you will hear, has a wealth of information to offer as we dig deeper into food security and climate change. Over to you, Richard.
Thank you very much, Suzanne, and happy Earth Day to everyone. I'm delighted to participate at this webinar with Kevin from Utooni Development Trust, a partner I've been privileged to collaborate with since 2019. Listening to Kevin and seeing his slides reminds me of the many reasons PWRDF values the partnership. First and foremost is the emphasis UDO gives to promote conservation agriculture in its work with farmers like Joyce and Gumbao, who you see here, outstanding in her field. Joyce is a highly skilled farmer and a mother of 5 children who range from 7 to 21 years of age. Kevin has explained how conservation agriculture has made a difference to improve food security for communities in the drylands of Southeast Kenya in a very visual way. We have seen the fields and appreciate the yields. Production will always be an important part of food security and an ongoing challenge with the extremes of climate change. It makes sustainability and care of creation all that more vital. Before you is care of creation above ground. I invite you to imagine what is going on below the surface. There is a whole world of life underground, which is not visible to the naked eye, and in many ways it is the next frontier to explore. Within one handful of healthy soil are more microorganisms than humans that have ever lived on the planet. It has been estimated by soil microbiologists that the weight of soil microorganisms are 10 times the weight of all humans and animals above ground. In a natural soil environment, in for example, this Garden of Eden, a cooperative relationship exists between microbes and plants. Plants like grass, trees, and food crops here depend on microorganisms in the soil to obtain water, solubilize nutrients, protect from pests and pathogens, prevent nutrient loss, and break down compounds that could inhibit growth. These soil microbes, in return, benefit from the health of plants growing in the soil and substances secreted from root systems. This relationship creates a dynamic biosystem driven by effective nutrient and water cycles, energy flow, and biodiversity. So let's go underground just for a moment to focus on one microorganism known as mycorrhizal fungi to understand why they are important. Yes, we're talking about mushrooms, but focusing more on what happens underground, undetected. According to the holistic farmer and author Michael Phillips, mycorrhizal fungi are important because they are the main means by which atmospheric carbon is sequestered into the soil. So what are mycorrhizal fungi? Well, they're naturally occurring fungi, beneficial in all ways, just like diocesan representatives, unpaid workers doing fantastic work, all goodness. They form symbiotic relationships with plants, they attach to roots and become extensions of the root system. They dramatically expand access to moisture and nutrients from the soil. In return, the host plant feeds the fungi with sugars and organic substances. Here you see a strawberry plant root magnified at least 400 times in order to see the vesicles of the mycorrhizal fungi, which have been stained blue for visibility inside the root. Note the hyphae at the top that is connected to the spores that would normally extend outside the root into the soil if it were not on a specimen slide for a microscope. Before you on the right is a diagram that depicts the magnification of a root of a plant underground. Inside the cells of the root on the left, in blue, are the spores of mycorrhizal fungi. Exiting the root are 2 strands that depict the hyphae of the mycorrhizal fungi that extends into the soil to transport nutrients and water to the roots of plant. Note the hyphae extend into the voids or air spaces between the soil particles, depicted in brown, to facilitate the exchange of gases and moisture, since it is these micro in-soil reservoirs where rainfall is stored. Healthy soil after all, is 66% voids, or air, or spaces between the soil particles. The fungi secrete an enzyme that solubilizes nutrients of soil particles and transfers them to the root of plants. Plants, in turn, secrete as much as 40% of the liquid carbon they manufacture during photosynthesis through the roots to feed microorganisms such as fungi. The mycorrhizal fungi transform that carbon fuel, and when the hyphae die, it turns into a glue-like substance known as glomalin that effectively connects and binds soil particles of carbon and minerals such as nitrogen, phosphate, potassium, and a variety of micronutrients and fungi. Glomalin plays a major role with roots to improve soil structure because it holds soil in clumps. On the left, we can see that fungi extend from roots of plants to such an extent they can multiply access to water and nutrients up to 700 times. Not only do they extend the reach in the search of water and minerals that plants require, the sheer density of the microscopic fungi, as you see on the right, this is a magnification, can be as much as 25,000 kilometers in 1 cubic meter of soil. Before you is a summary of the benefits of mycorrhizal fungi that emphasizes making water and nutrients available to the roots, which facilitate the growth of plants. The fungi do much more than what is stated in the summary, however. In addition to producing glomalin that improves soil structure to hold more water and nutrients, vesicles of fungi inside the roots store nutrients, lipids, and water as reservoirs when supplies are limited. Mycorrhizal fungi feed phosphate solubilizing bacteria that release enzymes that make available phosphate that is often present in the soil, but unavailable to plants without the byproducts of these bacteria. Mycorrhizal fungi also protect roots against other fungi causing root diseases and make plants more resistant to pests and diseases in general. I could go on, but the gist is that there is a lot of intelligent, complex, microscopic life in the soil, facilitating symbiosis between plants and microorganisms that we are only beginning to observe and understand. So let's return to the surface. See what happened in these two images. Imagine what must have happened below ground. What soil ecology could withstand this clear cutting of forest in North America on the left or the Amazon forest on the right? What microorganisms in the topsoil could survive the heat of sunlight of what is now predominantly bare ground to what they were accustomed to when under our ground cover and protected in the shade? Even if they had survived, where would microorganisms have gotten the carbon fuel plants and trees make during photosynthesis and secrete from their roots to feed them? There are approximately 14 billion hectares of land on Earth, though admittedly this is decreasing due to rising sea levels. 6,000 years ago, forest covered 8 billion of these hectares. Now forest only covers 3.5 billion hectares. But even with only less than half of the forest that once stood, they still play a major role to draw down 120 billion tons of carbon dioxide each growing season out of the total of 130 billion tons that are emitted into the atmosphere each year, leaving 10 billion tons that are added to the legacy load of carbon dioxide in our atmosphere. Though 350 million hectares of forest burns annually, that does not include bad years experienced lately with fires in California, Australia, and Brazil. In recent years, forest fires now emit more carbon dioxide into the air than fossil fuels. In Canada, some forests now emit more carbon dioxide than they draw down due to out-of-control fires. It has gotten so bad that Environment Canada no longer lists forests as a carbon dioxide sink. The burning of forests, however, pales in comparison to the 2 billion hectares of grasslands, rangelands, and crop residues that are burnt every year. Instead of incorporating that carbon into the soil, it is burnt and released as carbon dioxide into the atmosphere. On the right, you can see, if you could just return, Janice, is an example of slash and burn agriculture, which is a traditional form of agriculture primarily used in Kenya before organizations like UDO came along with conservation agriculture. Okay. If not burnt, but just left undisturbed, on the other hand, grasses die. They turn brown and then gray as carbon within them is oxidized until completely moribund, as you see here. Though slower than burning, the process is similar in the sense that it is a chemical change from the solid carbon to the gas, carbon dioxide. Left undisturbed, as we see here, in seasonal rainfall environments like Kenya, grasses die, increasing the bare ground between plants in a process known as desertification. So what to do? It reminds me of one of the slogans used by one of my professors in Ecology 101. If you can't beat it, just eat it. The other option, of course, is for a herbivore to eat the grass before it dies, and then carbon is returned to the soil in the form of dung and buried into the soil by a host of microorganisms and insects, such as dung beetles. The transformation from the solid grass to dung is therefore a biological change, not chemical. Herbivores need grass to survive, and grasses need to be reinvigorated through the pruning and fertilization by herbivores. The two have co-evolved for millennia in grassland environments. Keystone species such as buffalo on the prairies, caribou in the far north, and wildebeest in savanna Africa have been the custodians of grasslands for thousands of years. Moving on to plowing and tilling. Plowing and tilling are an integral part of agriculture as we know it, widespread throughout Kenya and the world, but it has a negative impact on biodiversity and global warming. Though plowing is a process that comes in many forms, essentially, the top layer of soil is overturned. It's sort of like flipping a pancake. Tilling, on the other hand, is a process whereby soil is cut and broken into smaller pieces, sort of like pulling a comb through the soil. What these two processes have in common is they both disturb and break up the soil, causing a lot of problems. When plowing and tilling, the plants in the top layer of the fields decompose, producing and releasing carbon dioxide and methane in the process. Fields that are not tilled, on the other hand, or minimally disturbed, contain subsoil fungi and plants with roots that extend deep and allow carbon sequestration to occur. Hence, by not plowing or tilling, the potential for carbon sequestration is unleashed. Within the European Union, under current conventional farming methods, 5% of the total greenhouse gas emissions come from the plowing and tilling of agricultural soils. That's more than aviation and shipping combined. You can imagine when soils are plowed and tilled year after year, large clumps of soil break up smaller and smaller until they look more like dust, which can be carried away by the wind or washed away by the rain. Tilling also kills a lot of the beneficial worms and fungi, which facilitates infiltration of rainfall and holds soil together to prevent erosion and retain a film of water around soil particles. The GMO is an organism whose genome has been engineered in the laboratory in order to favor an expression of desired physiological traits or the generation of desired biological products. This differs from plant breeding, where genetic engineering was within the genome of the same species, like corn. With GMOs, however, recombinant genetic technologies are employed to produce organisms whose genomes are altered at the molecular level, usually by the inclusion of genes from unrelated species of organisms that code for traits that would not be obtained easily through conventional selective breeding. For example, if we desire corn to be more tolerant to cold, we can select a cold tolerant trait from the gene of a goldfish and insert it into the genome of corn to make it more tolerant to cold. In order to sell more Roundup and seeds, the multinational Monsanto company has developed seed to be tolerant to the herbicide, such that it grows without competition from weeds. The short-term gains have unfortunately come with some unintended consequences, such as the reduction of milkweed plants that is the only source of food for the monarch butterfly. The decimation of monarch butterflies is paralleled with the weakening of bee colonies, due in part to the reduction in plants killed by Roundup and other herbicides. Should we lose nature's pollinators, the consequences for production of agricultural produce and food security could be catastrophic. Everyone knows if we use too much synthetic fertilizer, you can burn plants, but many of the ammonia, the sulfates, nitrates, urea, and other compounds can also kill the soil microbiology. As the combination of fertilizers and herbicides, pesticides get worse, the biology dies off and plants become more addicted and dependent on the chemical inputs. So over time, we have to spend more money to get the same growth out of our soil. Consider, for every excess gram of nitrogen fertilizer added to the soil, it oxidizes 30 grams of carbon to the atmosphere. It's just part of the natural composting process. The diagram you see before you shows how plants absorb nutrients. On the left, organic fertilizers that contain minerals that include carbon are fed to the soil, which is alive with microorganisms. And as we have learned today, also tap into their vast network to transport additional nutrients from the soil profile to the roots of plants. The roots in turn exude a carbon fuel rich in sugars and amino acids to feed the microorganisms in symbiosis. On the right, on the other hand, synthetic fertilizers are placed in the ground around the plant, but are absorbed directly by the roots of the plant and ignored by microorganisms, if not already killed, since synthetic fertilizers are not what sustains them. It's kind of like industrial hydroponics in soil instead of water. Basically, the value added by microorganisms is eliminated in conventional agriculture. This might have profound effects we're not fully aware of yet. We need microorganisms in our stomachs and digestive tract. Though we chew food into smaller pieces, it is not in a form that our bodies can absorb. We depend on microorganisms to eat and digest the smaller pieces in our stomachs and intestinal tract. They consume the smaller pieces we chewed and transform them into a form that our bodies can absorb and derive energy. Whatever fiber remains, we expel. Without this symbiosis with microorganisms, we cannot survive. Devices in university laboratories today that measure vitamins and minerals in fruit, vegetables, and cereals show that we are ingesting on average only 1/3 of the nutrients our grandparents consumed. While this might be due to many factors, I cannot help but wonder if it is partly linked to the decreasing fertility of our soils. And for those of us who primarily eat food produced by conventional agriculture, are the microorganisms in our bodies missing out on something or suffering in some way? It is said that we are what we eat. Is there a link today between food produced by conventional agriculture and some diseases linked to nutrition, such as obesity, diabetes, Alzheimer's, and dementia. Why do we still feel hungry shortly after eating a meal? Is the decreasing amount of vitamins and minerals in our food causing us to overeat? Perhaps, I'm just looking for excuses, but I cannot help but think that nutritional integrity is also part of food security. We should be concerned about when determining how we wish our food to be produced. A healthy soil is loaded with microbes and biological life. However, decades of conventional agriculture has slowly killed off much of the biodiversity in our soils. Synthetic and chemical pesticides and herbicides slowly and continuously kill off this beneficial biology in soil by raising the toxicity levels in the ground. These products are designed to kill negative biological forces, but after repeated use, these products end up killing far more than their intended targets and destroy much of what they come into contact with. Many weeds are becoming resistant to herbicides. With repeated use, weeds build up tolerance, and each application becomes less and less effective. Pesticides include a large group of chemical agents that attempt to eliminate destructive biological forces in agriculture. These include herbicides on the left for killing weeds, insecticides in the middle for killing insects, fungicides on the right for killing fungi, and bactericides for killing bacteria. While these chemicals supposedly only target specific species, repeated use inevitably kills microbial life that is beneficial to the soil system. Microbes that survive can be genetically altered in a way that is no longer beneficial to the soil ecosystem. In front of you is a diagram developed by an institution that promotes pesticides. It is implied that pesticides are absorbed by the crop and soil particles. Then it is degraded by chemical reactions or certain bacteria in soil, or it's leached beyond the root zones of plants. What pesticide drifts and vaporizes into the atmosphere, on the other hand, is eventually degraded by sunlight. What is not degraded gathers in clouds and delivered back to earth by rainfall, or runs off or leached to lakes and rivers. Before you now is an explanation from the previous diagram. Note on the left-hand side, in point form, the implication is that no harm is done by pesticides since they are absorbed into the soil, leach past the root system, become volatile, escape into the atmosphere, where they are degraded by sunlight or broken down by chemical reactions, or even degraded by some bacteria. Let's assume these points are correct. It still does not diminish the admission at the very top under the title that pesticides are degraded into carbon dioxide and emitted into the atmosphere. Irrigation is undoubtedly the most seductive aspect of conventional agriculture. The short-term benefits or gains to extend the growing season and increase productivity are incredible. Over time, however, they harm the growth of fungi and other microorganisms that are key to long-term productivity and resilience. There are many examples of past civilizations, such as Mesopotamia, that boomed with the invention and implementation of irrigation and then collapsed because irrigated fields became saline deserts and no longer support vegetation and microbial life. Following is land that has undergone plowing and harrowing and has been left unseeded for one or more growing seasons. It's a technique used for millennia with the objective to rest and restore land. We know, however, that disturbed soil releases carbon dioxide to the atmosphere. We know that when bare soil is exposed to the sun's rays, the heat retained kills microorganisms in the topsoil. We know too that some microorganisms cannot survive long unless they have access to roots of plants that leach sugars and amino acids for them to consume and thrive. So in conclusion, most of the inputs of conventional agriculture that we've mentioned today, whether it be clearing, burning, plowing and tilling, genetically modified organisms, fertilizers, biocides, irrigation, and fallowing, one way or another, put carbon dioxide into the atmosphere at lower productivity. Take an example in Canada. The prairies in North America used to be one of the most fertile soils on the planet. When the buffalo roamed, the organic matter ranged between 18 to 20%, and now it is less than 1% with the removal of buffalo and the growing of grains through conventional agriculture. Now, moving on to the sequestering. The emphasis of conservation agriculture, on the other hand, is to rebuild the soil carbon sponge that has been popularized by a very famous microbiologist, soil microbiologist, and climate scientist, Walter Haney. Every gram of carbon put into the soil holds an extra 8 grams of water. Recall that 66% of healthy soil is just air, voids, or spaces between soil particles that allow for the infiltration of rainfall and storage of it underground for slow release to roots when needed. The soil carbon sponge allows for the longevity of green growth to continue longer throughout the growing season and extends the drawdown of carbon dioxide and its sequestration into the soil that in turn increases productivity. Every gram of carbon added to the soil massively increases the fertility of soil. 80% of the fertility of soil is due not to the nutrients in total, but the availability of nutrients made possible through their solubilization, fixation, access, uptake, and cycling to plant roots by microorganisms. Fertility is mainly due to microbial ecology, not necessarily the nutrients in the soil or the fertilizers added. It is microorganisms that drive the availability and movement of nutrients. 1 gram of carbon put into the soil also massively increases the rootability of the soil and the volume of access roots have, which also leads to greater microbial activity, disease resistance, production, and resilience. When you think of it, increasing carbon into the soil has always been nature's way to increase productivity and resilience, not agricultural inputs. Why do we need these inputs when we can store stable carbon into the soil naturally and safely instead of releasing more carbon dioxide to the atmosphere? Thank you.
Thanks so much, Richard. I think between Kevin and Richard, we've just had a master class on conservation agriculture and some of the challenges around conventional agriculture. But before we all take the test about what we learned, I just want to ask a couple of questions that came up as we were preparing for this webinar and some conversation that we had. So back to you and Kevin, Richard. We tend to use terms that mean different things to different people, and like conventional agriculture, conservation agriculture, etc. We've had a question: is conservation agriculture and regenerative agriculture, are those the same things, or are they different? So sort of 2 levels of questions here. One is just a bit of explanation of terminology, and the other, I think, might be a question for Kevin. A lot of the images that we were seeing in Richard's presentation are probably what farming looks like to us here in North America. farms vary in size, to be sure, but a lot of those conventional agriculture images look like the big farms of the prairies. And so, Kevin, I wondered if you could just help us get a sense of, when you talk about farmers and farming in in Kenya, what size of farm are we talking about? Because it's quite different, I think, when we talk about farming in Kenya versus farming in Canada. So maybe we'll start with that one, and then I'll ask Richard to do the definition question. So could you just paint a picture for us of what size of farms, what are the nature of the farms that farmers in Kenya that you work with are working on?
Okay, thank you very much, Suzanne. First, I'd like to comment about the size of land in Kenya. And I would like to say that in Kenya, the population has grown in the past 3 decades. And Kenya is a small country, but with a very high population. And I'd like to say the average size for a small-scale farmer, because most of our farmers are smallholder farmers, is you'll find a family, the average size of a smallholder farming family is around 4 to 5 acres. When you move to the more fertile areas, high altitude, it even goes down to finding a household owning an average of 2 acres. So when I talk about 4 acres, 4 to 5 acres of land, I like to say that these are family with around 6 family members. So you have the spouse, and then they have maybe 4 children. So if these children grow and are above 18 years old, these pieces of land are divided amongst the 4 children, and each gets less than an acre, because the parents also need to be left with some land for farming. So size of land is also an issue for our farmers, and that's why we promote conservation agriculture, because with conservation agriculture, you're able to get more harvest in a small size of land compared to traditional farming. I can see there is somebody else who had asked about conservation agriculture and regenerative agriculture. I'd like to say that regenerative agriculture is a component of conservation agriculture. It is something that we've been also promoting amongst our farmers. The most common regenerative agriculture is farmer-managed natural regeneration, where we are trying to regenerate trees that were cut down some time ago, leaving the branches to regrow again, and regenerating these trees again to start serving communities. Thank you.
Thanks very much, Kevin. Richard, do you want to pick up on some of those questions around definition and when we're talking about farms, what we're talking about?
Sure. No, and one of the wonders of today is I can quickly ask Google for a good definition on regenerative agriculture. So let me just read that to you. According to Wikipedia, is a conservation and rehabilitation approach to food and farming systems. It focuses on topsoil regeneration, increasing biodiversity, improving the water cycle, enhancing ecosystem services, supporting biosequestration, increasing resilience to climate change, and strengthening the health and vitality of farm soils. Practices include recycling as much farm waste as possible and adding composted material from sources outside the farm. So that's the formal definition there. With conservation agriculture, I won't give you a definition, but to just mention the 3 pillars of conservation agriculture that Kevin mentioned in his presentation, which is minimum disturbance to the soil, through minimum tillage, ground covers, and he mentioned a lot of the cover crops. A lot of that is nitrogen fixing beans. He mentioned one with the Latin name Dolichos lablab, which is just a bean, and is in certain countries such as Kenya, particularly amongst the Kikuyu tribe, is really a staple that you just have to produce when you have visitors, otherwise they won't leave your home. Very important crop. Then the third component of conservation agriculture, as Kevin mentioned, is crop rotation and association. So two concepts there. The crop rotation is simply in using the same piece of ground, you're changing the crops each year, mindful of how much nutrients they're taking out of the soil. So in one year, if you maybe had heavy feeder like corn, in the following year you might put in a nitrogen fixer like beans. And then association is which Kevin also mentioned and showed examples of, combining crops together and sort of like guilds, where one output of one plant might be the input of another. And the obvious example of that is nitrogen from beans to a heavy feeder like corn plants. So I don't know if that answered the question, but that's the essential thing. So I sort of see conservation agriculture as a component of regenerative agriculture, but in the way UDO has implemented, they're really doing regenerative agriculture too. You noted how they are also incorporating livestock into their arable agriculture, which is not really formally put into conservation agriculture per se in the three principles, but it is very important because plants and animals, we all co-evolve together. We cannot just vilify one animal. Often you see cows and goats being vilified for the destruction they do, but it's a bit of a scapegoat because it's more their management that causes a problem. It's not the actual goat or cow that's a problem. It's really how they're managed. I mean, goats, cows, they're resources. I mean, it's all how they're managed that makes the difference. Thank you.
Thanks, Richard. So we'll remember that goats aren't necessarily scapegoats. And I just wanted to point out, Chris Farrell made an important comment here that, which I think goes to this question of how we use definitions and really being, I think, mindful of the different ways that those get used. He mentioned that in Canada, many conventional farmers are good stewards of their land. They have environmental farm plans, employ many practices that are sustainable, and he lists those there in the chat. So invite people to have a look at that. I'm just going to go back then to some questions that came up following Kevin's presentation. One was a question of, I think you had mentioned that one of the trees that can be planted, Kevin, are avocado trees, and a question about, wonder about the whether they are a tree that needs a lot of water.
Thank you, Suzanne. I think I saw that question. Somebody had asked if do avocados use a lot of water. One thing that I like to say today, being Earth Day, is that we should be good stewards while we are working on Earth. And I like to say that the reason why nowadays people are complaining that that tree consumes quite a lot of water, we should ask ourselves, these trees have been here for ages. Why is it that people are saying that eucalyptus is now consuming a lot of water? And maybe some others, I hear them saying acacia is also consuming a lot of water. These trees have been here for centuries. It's upon us human beings to improve water, retain water into the soil. It is upon us human beings to improve soil fertility. It is upon us to strike a balance in our farming practices in order to make sure that we are not avoiding growing certain trees because we are complaining that they are taking quite a lot of water. Even though climate change has led to some trees being mentioned that they take quite a lot of water and many people want to avoid planting them, I'd like to say that we have a responsibility to provide water to trees. I'd like to answer that question directly by saying that avocados don't use a lot of water. And again, they are drought resistant and they do very well in arid and semi-arid lands. But initially, after growing, you'll have to irrigate it for some months before it matures. That's a good question. Thank you.
Thank you, Kevin. And this goes to this question, which came up earlier, has to do with a fundraising effort that was undertaken by a parish in Hamilton, just west of Toronto. The parish supported fundraising for the implementation of a well and pump. Could Kevin explain how this helped with food security? How many people would a well and pump support? How many farmers, perhaps?
Yeah, thank you very much. I would like to answer that question too about shallow wells and hand pumps. I like to say that shallow wells have several benefits. They help to improve food production because farmers are able to use water from shallow wells to irrigate tree nurseries for them to germinate seedlings so that they can transplant during the rainy season. Shallow wells also enable farmers to practice irrigation, and the mostly irrigated crops are vegetables. During the dry season, vegetable supply in the arid and semi-arid lands is very low, and therefore community members are able to irrigate vegetables for community members to access vegetables nearer their households. The other important benefit of shallow wells is that there is improved quality of water for household use by family members, unlike the common scoop holes that are very common in the rural areas where community members dig a scoop hole along seasonal rivers to access water during the dry season. These shallow wells really help to improve the quality of water among its community. The other thing that we have observed recently is that shallow wells also provide safety for women and girls while fetching water. Sometimes during the dry season, you find that in the African setting, women and girls have to wake up very early in the morning to go to the river to fetch water. And they have to dig very deep wells to access that water from rivers. But with shallow wells, you find that shallow wells are located in open places where women and girls feel secure while fetching water, maybe late in the evening or early in the morning. There is also another benefit of shallow wells. There is less contamination. There is less contamination of water because most community members go to the water source with donkeys. So you find that when a community has a shallow well, livestock cannot contaminate that water. Even if the waste is just somewhere around the well, it really doesn't go inside the water compared to other open surface, open water harvesting storage facilities. With regard to the number of beneficiaries one shallow well would benefit, I'll say at least 500 households benefit from one shallow well. Thank you.
Thanks, Kevin. I think maybe this is a question for you, Richard, coming from Polisi. Is there any attempt to address the issue of chemicals in America and Europe in the same way as we are sensitizing people to avoid bushfires in Africa? You want to have a go at that one?
Oh, yeah. I think so. I mean, you just sort of do have two camps, for and against. And it's an ongoing battle. I mean, we all see it. But yeah, I don't think there perhaps is enough of it. And it's not only forest fires in Africa. There, it's more of a issue of grassland fires because of the savanna covers the vast swath of the continent. But look at all the forest fires in all the other continents. I mean, my goodness, you've seen what's happened in California, Australia, and Brazil, where just thousands upon thousands of hectares have gone up in smoke, and all the biodiversity that goes with that forest, not only the animals we see above ground, but what goes on underground and sustains those animals and insects above ground.
Thanks, and I think that would also ring true for us in Canada, where we've had major forest fires in recent years. Another question for you, Richard. Could you provide the sources about the diminished nutrition in food today? You had mentioned the statistic of decreased nutrients in our food.
Yeah, I said 1/3. I'll have to come back to you on that one,
Okay.
but I can give you an end note for that. I don't have it off the top of my head.
Great.
We can
thanks.
send a link along if you find it
Yeah,
with the recording.
Yeah, sure.
that's great. Okay. I think I'm hoping I've not missed anyone's question in the chat at this point. Does anyone else have a question for Richard or Kevin? We have a few more minutes. Oh, I think there's a new one
Hi,
there.
sorry. I don't have a question. I just wanted to mention that there's a documentary out on Netflix called Kiss the Ground, which will reinforce everything that Richard has just talked to us about, and Kevin as well, if you need that kind of visual aid. It was very, very good. So I just wanted to recommend that, Kiss the Ground.
Yes, Richard, we watched a trailer of that at a previous webinar, and yeah, very inspiring.
Yes, I wanted to mention that at the end of my presentation, that film is a source of inspiration for me, and even Kevin as well. Kevin's got his whole staff watch that movie, I think more than once, and with discussion afterwards. It's a very thought-provoking movie, which really gets to addressing that we have to think of the soil, and that's why it's entitled "Kissing the Ground" on Netflix. Highly recommended. Everyone watch that.
Lynn's asked a question about our so-called organic foods we see in stores using improved farming practices as you described.
Could you please repeat?
Our so-called organic foods that are sold to us in grocery stores, are they coming from farms using improved farming practices as Kevin and you described?
Well, they're certainly supposed to. I mean, there have been some exposés in the media that people have taken advantage of that. Some of the products are not necessarily organic, so I wouldn't want to say that all of them are legitimate. I think there has been some abuses whereby some conventionally produced food in some way or another has gotten into the organic market, so buyer beware.
Thanks. Any last question for Kevin or Richard? Polisi?
Thank you. I wanted to clarify about the question I asked about agroforestry, explaining that in our area, people often confuse agroforestry and reforestation. So when we explain to people that we are cutting trees and there is another challenge that they need firewood, and they find that eucalyptus grows faster and you can get money easily. So they are replacing fields where they used to plant food crops by eucalyptus. So it will have a negative impact. That is what I wanted to mention. And then thinking that if we want to say protection of the environment, there are some tree species that we can plant in fields. Okay, I didn't mean trees. I meant these species which can be planted in fields and contribute at the same time, even for firewood, but also even facilitating fertilizing the soil. That was my question, but Kevin has answered. I just want to clarify what I meant by the component of eucalyptus, which has a problem of survival for firewood and replacing now the food crops by eucalyptus.
Thank you. That's very helpful. Kevin, did you want to say anything further about that?
Thank you very much, Polisi, for that clarification. And I think we're also facing the same challenge here in Kenya, where most community members want to plant eucalyptus along rivers for income generation because they fetch good money once they are mature. And there's been quite a lot of controversies about the eucalyptus trees. So I think it's something that is ongoing in Africa. But as I had said, we have also a responsibility to avail more water during the dry season, so that we are not just getting rid of trees because they are just taking, we are saying with the excuse that they are taking quite a lot of water. Soon every tree will get rid of every tree, because we'll keep saying that these trees are taking quite a lot of water, and before we know, we'll have gotten rid of many tree species without knowing. So we really have a responsibility, we as good stewards, to really take care of the environment, and also to coexist with all the vegetation and also with all the living organisms that God created in this world. Thank you.
Suzanne, can I just add one thing?
Yep.
Just to going to the question about the eucalyptus trees, and I think it just sort of speaks to the pressure that people are under in, especially in parts of in Kenya and other parts of Africa, where there is a real need to grow things quickly to make make money to feed your family. And I think, is that, Kevin, one of the reasons why maybe making the switch to conservation agriculture, or educating people about that was kind of a change, because it takes a little bit longer maybe, but the benefits are there. It's worth it in the end. Is that kind of fair to say?
Yeah, thank you very much. I think one reason why we introduce conservation agriculture is to increase moisture in the soil, and also to enable community members reduce the cost of farming. The cost of farming has been going high every year here in Kenya. You find that most seeds which are being sold by input suppliers are GMOs or hybrids, which are quite expensive and you cannot replant them. You also find that the cost of labor here is very expensive nowadays. And also you find that the cost of farming equipment is also very high. And therefore, we thought that conservation agriculture would help community members in the long run to reduce these costs. And so far, we are seeing very good results. Farmers are reporting reduced cost of farming. They are also reporting that it's not much. It's the amount of labor that they have to put in their farm is also reducing drastically. Another reason why we promoting conservation agriculture is to bring youth to adopt farming, to take farming as an income generation activity, because you need less inputs when you are doing agriculture, the conservation agriculture way, rather than the traditional way. And for a long time, our farmers have been complaining that we've been putting quite a lot of money in our farms, but we really don't get it out. We even if I harvest very little from 2 acres of land. But now we are hearing farmers say that in half an acre, I harvested 3 bags of maize and harvested 4 bags of beans. And such stories are motivating us very much. And also community members are continuing to put more land under conservation agriculture.
Yeah, I just wanted to add to Kevin that I think it's important to remember in his presentation, he said that a certain percentage of farmers embraced 1 technique, then 2 techniques, then 3 techniques of conservation agriculture. So it's a learning experience, and we need to remember that these are small-scale farmers with very very little amount of land. They cannot afford to take risks, and so the main thing is to initially gain their trust and deliver on their needs, which is putting food on the table. And that starts with so whenever you consider ground covers, you have to think of ground covers that actually also produce food, even though there are others available, which might increase more biomass, but not necessarily produce food. So it really is an iterative thing where I really have a lot of respect for UDO because they allow farmers to learn at their own pace, and they support them with interventions as they're ready to adopt them. So things, for example, like implementing more agroforestry might take some time because you don't necessarily see an immediate benefit above ground when planting, for example, nitrogen fixing trees. in there, and we have to be quite open-minded. Each environment is different in Africa. In one area, you may support eucalyptus, in other areas not. In the UDO situation, they really are in a very arid part of the ground where they are concentrating on food, producing fruit trees. He didn't mention, however, there's one other, it's more of a hedge than a tree, but pigeon pea is planted as well, which really, produces protein, the food, but also has very long roots, which act just like trees and fixing nitrogen into the soil. So it's all very much related to the environment and growing with, growing together and learning and trying new things. And that's why you do see a big difference. You notice that the farmer I showed, I was stunned with her ecological understanding. And she's a master farmer in my mind. And that's come after many years, I'm sure.
That's, I think, a good note to end the questions on. And I'm sorry, we could probably keep going, but we do want to respect people's time. And we do have one more piece that we want to introduce before we send you on your way. So a big thank you to Kevin and Richard for very informative inputs. And if you do have further questions, please send them to us, and we'll refer them to Richard and or Kevin as needed. So Janice, would you mind, could you bring up our website? Some of you may be aware that earlier this year we launched what we're calling an education focus for the next 3 years that we've titled Creation Care Climate Action. And this webinar is one of the offerings of that education focus. We want today, on Earth Day, to launch another aspect of the focus, which is a series of learning modules. And they're being designed in response to input that we received from a small consultative group and a survey that some of you responded to late last year. We're hoping that this online resource will be used at local and regional levels, and we can offer support as needed to those who would like to hold any sessions. So we're going to have a focus for each year of the education focus, and the theme for year 1 is climate action and food security, which makes sense given the webinar we've just had. The theme for year 2 is climate action and women, and in the 3rd year we will be looking at climate action and health. And so these learning modules are designed, online learning modules designed for individual, to work through individually, or probably preferably with a group if you had the opportunity. They take about an hour to 90 minutes each. And we're offering them only digitally, in keeping with our commitment to caring for creation. So we're trying to be as paperless as we can with this set of resources. The 5 modules for this first year will focus around the agricultural seasons and will be released starting today, and then over the course of the year through to next March. And so the first one focuses on rogation, or planting. The second will be on the season of creation. The third on Thanksgiving, or harvest. And then the fourth on Sabbath, Jubilee rest, and planning for the next planting season. And early next year, we'll release one on waiting or preparing, which will have a focus on climate disasters and their impacts on food security. Each of the 5 modules will follow a learn, reflect, act, and give pattern, and we'll begin and end with prayer. And so you can see here, this is the first learning module, rogation, the planting of seeds, with a little bit of an introduction, and throughout tips on how you might consider using it with a group. we recognize that meeting in person is not possible in many places of the country. So these can be, we're hoping, can be used online or hopefully eventually in person. We begin with an opening prayer, as you can see there, that comes from the Ecumenical Advocacy Alliance. And then get into a learn section. And we're grateful to our diocesan representative from Edmonton, Dorothy Marshall, who is a farmer, who has offered us some learning about rogation from her life as a farmer. We then offer a partner's perspective, a couple of partners' perspectives, one from Zimbabwe and another from Uganda. And one is a story from our website, another a video resource. And then some questions for you to consider, again, either individually or as a group, to try and tease out a bit together what you've learned and and how you respond to that. Then there's an opportunity for some theological reflection, looking at agricultural images throughout the biblical texts, again with some questions for a group to consider. And then we offer a series of possible activities that you could engage in. One, as a group in the moment, planting seeds, and then some considerations, planting a parish garden, and a look at a few inspiring resources around that. One of which we've been mentioning inspiring movies. This is a really lovely movie about a parish in the United States that began farming in order to save the parish, and the role that the refugee community from Burma played in that. It's a really beautiful, based on a true story. And then there's some opportunity for advocacy actions, two ecumenical initiatives, one with the Canadian Food Grains Bank and another with For the Love of Creation, which is an ecumenical advocacy initiative that PWRDF is a member of. So, and then an opportunity to support the work of our partners who are engaged in these projects that are intersections of food security and climate change. And finally, a closing prayer. And I thought to end our session today, it would be good if we might say this prayer together. It may be familiar to some of you, but I think it really speaks to the being faithful in the work that we're about, not just on climate change, but other work. And it also speaks to rogation, which is about the planting of seeds. For some, it's become known as the Romero prayer, but it was actually written by a now deceased bishop in Saginaw, Michigan, Bishop Ken Untner. So if you'd like to stay on mute, we'll just read this through together to end our time. It helps now and then to step back and take a long view. The kingdom is not only beyond our efforts. Can I invite you to mute? Thanks. The kingdom is not only beyond our efforts, it is even beyond our vision. We accomplish in our lifetime only a tiny fraction of the magnificent enterprise that is God's work. Nothing we do is complete, which is a way of saying that the kingdom always lies beyond us. No statement says all that could be said. No prayer fully expresses our faith. No confession brings perfection. No pastoral visit brings wholeness. No program accomplishes the church's mission. No set of goals and objectives includes everything. This is what we are about. We plant the seeds that one day will grow. We water seeds already planted, knowing that they hold future promise. We lay foundations that will need further development. We provide yeast that produces far beyond our capabilities. We cannot do everything, And there is a sense of liberation in realizing that. This enables us to do something and to do it very well. It may be incomplete, but it is a beginning, a step along the way, an opportunity for the Lord's grace to enter and do the rest. We may never see the end results, but that is the difference between the master builder and the worker. We are workers, not master builders, ministers, not messiahs. We are prophets of a future not our own. Amen. So thank you everyone for your time and attention today, and please be welcome to engage with that resource.